Hi my dear students, welcome back to my channel. So tips and tricks for civil engineers. Okay. അപ്പം ഞാനിപ്പോൾ എടുത്തുകൊണ്ടിരിക്കുന്നത് ബയോഗ്യാസിനെ പറ്റിയാണ്. അപ്പോൾ ബയോഗ്യാസിന് എന്തായാലും ക്ലാസ് കഴിയാറായി. ഇനിയിപ്പോൾ എനിക്ക് തോന്നുന്നത് ഒരു 2 ക്ലാസ് കൂടെ ഉള്ളൂ. ഓക്കെ. ഇതുകൂടെ കഴിഞ്ഞാൽ 2 ക്ലാസ് കൂടെ കഴിഞ്ഞാൽ ബയോഗ്യാസ് കഴിഞ്ഞു. അത് കഴിഞ്ഞ് നമുക്ക് സോളറിലോട്ട് ഒന്നുകൂടെ പോകാം. ഓക്കെ. അപ്പോൾ ബയോഗ്യാസിനെ പറ്റി ഞാനിപ്പോൾ ഡിസ്കസ് ചെയ്യുന്നത്. നമ്മൾ ബയോഗ്യാസ് കിട്ടുന്നുണ്ടല്ലോ, ആ ഒരു ബയോഗ്യാസിൽ ഇംപ്യൂരിറ്റീസ് കാണും. അപ്പം നമുക്കിപ്പം അത് കുക്കിംഗ് ഗ്യാസ് ആയിട്ട് യൂസ് ചെയ്യുന്ന സമയത്ത് ആ ഒരു ഇംപ്യൂരിറ്റീസ് വെച്ചിട്ട് നമുക്ക് കുക്കിംഗ് ചെയ്യാൻ പറ്റത്തില്ല. ചിലപ്പോൾ നമ്മുടെ ഹെൽത്തിന് പ്രശ്നമാവും, ചിലപ്പോൾ ആ ഒരു ഗ്യാസ് കത്തിക്കുമ്പോൾ ആ ഒരു എക്യുപ്മെന്റിന് പ്രശ്നങ്ങൾ വരും. അപ്പം അതൊക്കെയാണ് ഇന്ന് ഡിസ്കസ് ചെയ്യുന്നത്. ഓക്കെ. അപ്പം ഈ ബയോഗ്യാസിൽ ഒരുപാട് ഗ്യാസ് വരും. അമോണിയ വരും, ക്ലോറിൻ വരും, അമോണിയ വരും, കാർബൺ ഡൈ ഓക്സൈഡ് വരും. അപ്പൊ ഇതൊക്കെ വന്നിട്ട് നമ്മൾ പെട്ടെന്ന് റിമൂവ് ചെയ്യണമെങ്കിൽ നമുക്ക് ഓരോ പ്രോസസ്സ് നമ്മൾ ചെയ്യണം. ഓക്കെ. അതിനെ പറ്റിയാണ് നമുക്ക് ഇപ്പോൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. ഓക്കെ. Today going to discuss about biogas impurities. Okay. Last class I already discussed. Here I am going to discuss about silicoids. Silicoids are highly water soluble and lead to second type of biogas impurities, having a significant concern during its applications. Silicoids are semi-volatile organic compounds contain silicon and used number of cosmetic industries like deodorants, detergents, food additives, and soap widely spread within the environmental components. This makes the silicoids abundant in the sludge of wastewater treatment plants. At the same time, contributed as main constant of biogas. At high temperature, anaerobic digester for biogas production volatilize natural silicoids could be entered as biogas constituents. The composition of silicoids in landfill gas WWT are expected to contain a maximum of 4 to 9 ppm and high as 41 ppm respectively. However, biogas in the farm digesters also contain least amount of silicoids, while no information could found from small scale biogas digesters like our residential biogas plants. We won't get enough amount of silicoids. Okay, that's explaining here. Ammonia is formed during anaerobic degradation of feedstock rich of protein. Okay. Ammonia concentration of biogas is generally very low, not exceeding 0.1 mg per Newton meter cube. A high concentration of ammonia in biogas may lead to formation of nitrous oxide during combustion. Ammonia formation can be avoided by controlling biogas flows as ammonia is formed at high pH and temperature. Okay. Adjusting carbon-nitrogen ratio, the feedstock can also avoid ammonia formation. Some ammonia is removed during CO2 removal process like absorption process with water or organic acid such as dilute nitric acid and sulfuric acid, and also with activated carbon. Oxygen and nitrogen. Okay. The presence of oxygen and nitrogen lowers the heating value of gas and cause corrosion. Oxygen and nitrogen are typically absent in all biogas except in landfill gas. Landfill gas contains relatively high concentration of oxygen and nitrogen as air may penetrate in the landfill gas collection system, which are operated by using vacuum through landfill cover. O2 and nitrogen may occasionally present in biogas due to leakage of air or oxygen is injected into the biogas reactor to control H2S. Removal of oxygen and nitrogen, if present in large quantities, it can be costly. Impede the use of biogas for vehicle and grid injection. Okay. Volatile organic compounds. The other constant of biogas are volatile organic compounds, which includes alkyls, alcohols, halogens, aromatic compounds, which are formed various concentration level depending on the condition of anaerobic digestion and type of biomass. The downstream equipments and pipelines are also affected by halogens, mainly due to corrosive products formed by reaction of halogens like chlorine and nickel-based catalyst, following by sublimation of reaction product. For example, gas phase nickel chloride for chlorine poisoning. Okay. However, the combination of chlorine in raw biogas is too low, thereby no further treatment is required for its removal. Next is the moisture content. The contents in the pipes lowers the sections of piping system, disturb the gas flow, increase the pressure in the digester. Increased corrosion by dissolving H2S. That deteriorate membranes or diaphragms in check valves, relief valve, gas meters, and regulators. Blockage can be detected by observing the manometer pressure at various points in biogas systems. Gas flow at this reduced velocity, moisture and sediment settle out of the flow and can be removed by providing drip taps at all spots along the gas collection system. Gas piping should be sloped at a minimum 1% towards the collection point. Additional removal of or cooling gas is and removed condensate. Okay. Uh, Carbon dioxide. Carbon dioxide is also a major disadvantage. When carbon dioxide combines with water, it will form carbonic acids. Okay, that is very dangerous. This will cause corrosion in the pipes. Okay, carbon dioxide contains in the biogas about 50 to 30 to 50%, depending on the feedstock composition and process conditions. Okay, carbon dioxide generally removed to increase the energy of gas and produce biomethane. Example, vehicle fuel use, gas grid injection. Carbon dioxide removal is usually performed after removal of water vapor, H2S, silicoates, NH3. Some carbon dioxide scrubbing technologies may also remove above mentioned contaminants. Common method of carbon dioxide removal are water scrubbing. Okay, we introduce the pressurized gas at the bottom of the packed column. It receives the water from the top. The pressure swing adsorption technology, and it is a cytogenic technique, etc. Okay. Next is the biomass impurities. I am going to explain. Means last class I already discussed about hydrogen sulfide. Okay. Today I am discussing about the threshold limit, how it affects the human and other environment. Then what will be the effect on the equipment? Okay. Hydrogen sulfate, its order is 0.014 milligram per meter cube. Okay. Few days of eye irritation means if you contact hydrogen sulfate for few days, it will will get the high irritation and respiration also. Okay, irritation about it should be less than 1 ppm. Okay, effects on human health environmental are hazardous to environment, forming SO2 and SO3 and acid rain. Okay, bad smell, eye irritation, and unhealthy. H2S is a potent nerve poison. Okay. Then the effect on process of equipment are it is highly corrosive and poisoning to the catalytic converter, toxic to PSA adsorbents. Okay. Silicoids are there is no threshold. Means we can have many means it does not have any limit. Okay. So the effects on human are no environmental effect, only responsible for fouling in the post combustion emissions, control catalytic system. Then the equipment what are the effects on the equipment are um, formation of glassy microcrystalline silica that decreases the lifespan of the equipment. Okay, next is ammonia. Ammonia is the limit explained here. It should be 50 ppm. During combustion, NH3 converts to NOx. NOx is a very highly air pollutant. Okay, it should be less than 10%. The formation of NOx after the combustion, effects on humans. Okay, toxic to anaerobic bacteria inside the biogas plant. Okay, then health problems, toxic and bad smell. Then what are the equipment problems? Corrosion, anti-knock properties to engines. NH3 is less corrosive than H2S. Nitrogen is no harmful environmental effect, and the effect on the equipment are it is reducing the calorific value, means it will not burn fast, that is reducing the calorific value. Corrosion and anti-knock properties will be present. Okay. Then water vapor forms acids with carbon dioxide and H2S. Okay. Then water vapor which causes the equipment are corrosion due to reactions with ammonia. Okay. Then particulate matter should be less than 20 microgram per meter cube for 24 hours, and the particle size is less than 2.5 micrometer. Okay. The effect on humans is no problems, but for the equipments, the flux of the gas system and pores of the adsorbent, means if it is present in the flux of the gas system, we cannot switch on the gas. Okay. Okay, this much only I am today taking class. Next class I am going to discuss about biogas impurities and their impact. Okay, means this only uh, continuation. Okay, thank you and all the best for exams.